Back in Chapter 2 and Chapter 3, we reviewed financial statements and some financial ratios. So we got some idea about how to evaluate the performance of a company and how to estimate the cash flows the company generates. Now, if we have some idea about how much cash a company can generate in the near future, the question is, how much would those cash flows be worth of today? That's actually what we will talk about here in Chapter 4, time value of money. Actually, Chapter 4 and Chapter 5 are both about the time value of money. In Chapter 4, we start with the simple, easy case when we only look at just one cash flow. And then in Chapter 5, we'll extend it to look at multiple cash flows. So, a simple question here. If you can have the choice, would you prefer to have $1 million now, or would you prefer to wait for 10 years and get the same amount? I would think that you would prefer getting the money now. So this tells you that you know this 10 years makes a difference in the value of this $1 million. So generally the idea is $1 today is worth more than $1 that's promised for later. We can say that this is because if you get the money today, even if it's just $1, you can invest it and make interest out of this $1, so you can have more in the future. So if you can only have $1 later, that's definitely not worth as much as $1 today. How much interest can you earn? That really depends on the interest rate, or say the rate of return. So in this chapter, we'll get some idea how to use the concept and technique of the time value of money to capture the value of $1 through time. The time value of money is based on usually three factors. How much money are we talking about? Is it $1 or $1 million? And how long are we talking about? So are we talking about 1 year or 10 years? And then what is the interest rate or rate of return that you can have? This time value of money is a powerful tool for us to understand the wealth accumulation and make reasonable financial decisions. So you can imagine it's widely used by financial managers, investment professionals. For this class, we'll try to apply the time value of money concept and techniques in many subjects, such as bond valuation. We'll talk about that in Chapter 7, stock valuation, Chapter 8, and project management, or say capital budgeting decisions, that will be Chapter 13. And also throughout the examples and practice questions in these chapters, you will see we can try to apply this time value of money concept in many areas, such as retirement planning, auto financing, mortgage financing, many areas. So again, it's one of the most basic and important tool in finance that I think every business school student needs to understand. Before we start any calculations, let's first introduce a tool to help us analyze the cash flows between now and the future. So what you're looking at here, this is an example for the so-called timeline. And essentially it's a line. And on this line, you see we have the time. So time 0, that's usually now, today. Between year 0 and year 1, we're talking about 1 year. And so this will be the end of the first year. And then 1 year later, this will be at the end of the second year. So you have year 0, and then year 1, and year 2. And on each time, you have the cash flow at that time. So $100 investment at time 0, and then 105 to be received at the end of year 1. So to summarize, cash that we receive is an inflow, and that will be a positive number. Cash that leaves us, that's a cash outflow, and we will use a negative number to represent that. So now if I ask you to draw a timeline, if you have to invest $40,000 today, or say time 0, in year 1, you get nothing. But then in year 2, end of year 2, you have $20,000, Again, that's in year 3, and then $40,000 at the end of year 4. So this is what I would have. You invest $40,000, so 40,000 negative at time 0, 0 in year 1, $20,000 in year 2, again 0 in year 3, and $40,000 in year 4. So the job is to line up the cash flows at the right time, and this way we take one look at this timeline, we know clearly how much cash flow occurred at what time. Now let's think about the so-called future value. Future value is the value of an investment after one or more periods. Here, if you make an investment of $100 and you make 5% out of this $100, then you will have 105 sitting in your account. So this 105 is the future value of your $100 investment today. This is the future value, 105, equals to what you have today, 100, plus the $5 interest, which is generated by your principal of 100 and the 5% interest rate. So I can write it as 105 equals to 100 plus 5, or 105 equals to 100 multiplied by 1 plus the 5% interest rate. For 1 year, or say the so-called single period, the future value simply is the present value, whatever you have now, multiplied by 1 plus the rate of return, or say 1 plus the interest rate. Now, what if we are talking about not just 1 year, but 2 years or 5 years? We will be looking at a process called compounding. Compounding essentially is interest generating interest. So when you have 105 at the end of the first year, the extra $5 interest will also generate interest at 5% return or interest rate. So if we are talking about 2 years, we are compounding the interest, and we will have a total of 110.25 cents. We can also try to use the financial calculator to solve for the future value. I also post a link to another video that demonstrates how to use a financial calculator to perform the basic time value of money calculations. You may want to check that video out before you continue here. Here, we start input the values of different variables and try to get the result in the financial calculator. So if we want to know the future value, we input 2 as n. We are talking about 2 years. You may have learned from my calculator demonstration video that to input 5% as the interest rate, you only put 5 instead of 5% as IY. You can put a negative $100 here as present value just to show that this is the money you invest. So cash outflow, negative. And you can leave this 0 as payment at this point, and then you compute for the future value, and you should get the results of 110.25, which is consistent with your result here. At this point, if you don't know how to use your financial calculator, pause here and go check out my video of the calculator demonstration and try a couple of practice along with that video, and then come back and practice with this question. Now, what if we want to find out the future value not in just 2 years, but in 5 years? In your financial calculator, you simply need to adjust the number of years from 2 to 5, so just 5 as n, and compute for the future value. You should get 127.63. You can also try to calculate by the formula. Future value would be $100 multiplied by 1 plus 5% at the power of 5. The result should also be 127.63. Now let's do a small experiment here. What if we change n, the number of years, from 5 to 20, and also from 20 to 40? what will be the different result of the future value? Here you can see the results under 20 years of compounding for $100 at 5% interest rate will be 265.33. And if we are talking about 40 years, the future value is about $704. The conclusion we want to make here is that when n, the number of years, double from 20 to 40, the future value result more than doubled. So 704 is more than twice of the 265. So the idea is that there is an exponential relationship between the number of years and the future value result. What's the relationship between interest rate and the future value results? Based on the same equation, same formula, if we change interest from 5% to 10%, now both calculations are under 40 years, we look at the future value results. So if interest rate doubled from 5 to 10%, future value definitely more than doubled. So again, there is an exponential relationship between the interest rate and the future value. Interest rate goes up a little bit, and then the future value actually can go up a lot. You can find this graph from your textbook. This is actually just to show you the so-called power of compounding. With $100 investments, you see the green section, which is the interest earned on interest, has grown substantially. So this is just an illustration for the power of compounding. Now you understand that compounding helps to build wealth or say accumulate wealth over time. We just talk about, for example, same 5% interest rate over time. What if in those 20 or 40 years, the interest rate has changed? It's not the same 5%. If it's not the same 5%, we'll just have to compound using the individual interest rates, or just have to do it year by year. So if we, for example, are looking at $2,500 investments, and then 7% for the first year, 8% for the second year, and 8.5% at the third year, all that we need to do is to compound year by year using the different interest rate at each year. So then after 3 years, we get a total of more than $3,000. And you understand, if the interest rates here are all the same, for example, all 7%, then you will have 1.07 multiply itself for 3 times, then you will have 1.07 at the power of 3. That will be the formula you saw before. But when the interest rates are all different every year, we cannot do that, so we'll just have to do it individually year by year.